In this video, let us discuss the design aspects of corner reflector. So, if you want to design any corner reflector, what are the things to keep in mind? The things discussed in this corner reflector. So, what is the design of corner reflector? So, let us take a corner reflector. So, what are the design? If I want to design a any corner reflector, so this is L. This is L length. Okay. And this is a driven element dipole. Okay. Driven element dipole. So if I want to design, okay, let us take this is L. What is this L? L is the length. Okay. And what is this one? This is DA. Aperture. DA is dimensions of aperture. And this is S. What is this S? S is the separation distance between driven element and S is the separation distance between driven element and vertex. Okay, so L is side length. L is side length. Okay, so in general, the side length L is selected equal to the twice of the distances. So the design next one is design of corner reflector. Design of corner reflector. So how will you select the length L? Always generally the value of length is selected as 2 times the separation distance. And so if you take the triangle DA, what is the formula for the DA here? DA is equal to, if you consider this as a DA, DA is equal to root of L square plus L square, that is root 2 L root 2 L. So DA is equal to 1.414 into L. Okay, so DA is equal to 1.414 L. So I can express L in terms of S, that is into 2S. Okay, so the different formulas for DA it is 2.828 S. Okay, so what are the different formulas for S? This is in terms of spacing between the feed element, and this is in terms of L is length of the reflector sheet, where L is length of reflector sheet, length of reflector sheet, and DA is, what is this DA? Aperture dimension. So this is from here to here, we call it as aperture dimension. Aperture dimension. So already I have shown here. So see here. So this is my DA from here to here. This is aperture dimension, and this is L. Okay, so this is L. Okay, so these are the design expressions. So what is the design expressions? L should be selected as 2 times the spacing between driven element and vertex. Okay, so for example, let us consider here the spacing, it is 0.5 lambda. So if the spacing is 0.5 lambda, so what should be the length? It is 2 times. 2 into 0.5 is equal to 1. 0.5 is equal to 1. And this is the radiation pattern. And this is the radiation pattern. Here, what is the value of S? S value is equal to 1. So if S is equal to 1, what should be the length of the reflector? 2 times. So it is, if S is equal to the separation distance is 1 lambda, the L value is 2 lambda. So this is the radiation pattern. Here, what is the value of S? The value of S is equal to 1.5. So 1.5 means the value is 3. Okay, so the value of length is 2 into 1.5 is equal to 3 lambda. So 2 into 1.5 is equal to 3 lambda. So the spacing S affects the gain and bandwidth. Okay, the gain and bandwidth. For small spacing, bandwidth is narrow and gain is higher. Okay, for broader spacing, bandwidth is broader and gain is smaller. Okay, these are the 2 things. Okay, so if you want go for beam width or bandwidth, you want to take more spacing. If you want to go for gain, you want to take less spacing. Okay, so these are the design of corner reflector. These are the aspects of design of corner reflector. So by taking this, This is the things, all the things regarding corner reflector.